Hey guys, it's Miss Adams, and today we're going to be looking at the 6A.7 Factoring Graphic Organizer in practice. So we're just going to be looking at the graphic organizer as a class, and then I'm going to let you guys work on the practice. The practice answer key is posted in case you want to go back and look to see what you did right, what you did wrong, figure out what you're doing. But we're just going to do an overview of factoring because that's what we've been focusing on in Unit 6A. So where do we start? Step one is you always want to put your equation in standard form. Remember, that's from your highest exponent to your lowest exponent. Step two, you're going to look for a GCF, which is your greatest common factor. So after you put an equation or your expression in standard form, you're going to then look for a GCF. If you have a GCF, factor that out first. Step three is to count the number of terms, because the number of terms is going to depend on which way we factor. So let's break this down by the number of terms. We've learned about 2-term polynomials, 3-term polynomials, and 4-term polynomials. Each way has a different way of factoring. So when you have a 2-term polynomial, you're either going to factor using the greatest common factor, or you're going to factor using dots, which is your difference of two squares. So let's just look at the greatest common factor first. We've given you this example, x squared plus 3x. Does it have a greatest common factor? We'll take a moment and look at that. You've got your two terms, x squared and 3x. Although they do not have a numerical greatest common factor, they do have a variable in common. So we can factor out an x. And when I say factor out, we're going to divide both terms by that x because we're doing the opposite of the distributive property. So I've got my x as my greatest common factor. X squared divided by x is going to leave us with x. And then 3x divided by x will leave us with a 3. And that is your factored form of x squared plus 3x. Then we get on to dots. Dots is our difference of two squares. This is a special case. Both of your terms need to be perfect squares, and it has to be a difference, which is subtraction of two perfect squares. So let's look at our first term. We've got 4x squared. I know 4 is a perfect square. That's 2 times 2. And x squared is a perfect square. That's x times x. So we can write its factors as 2x times 2x. Then I look at 25. 25 is a perfect square. Its perfect factor is 5 times 5. When you have a difference of two squares, your two factors will be set up, the factors expressions, as the addition of your terms and the subtraction of your terms. So in this case, I'm going to have 2x plus 5 and 2x minus 5 as my two factors. So we went from our standard form to our intercept form using dots. Now let's look at 3-term polynomials. These are the ones that take a little bit more time to work through. So stick with it, see what you can find out. If you prefer to use the diamond or the bottoms up method, that's fine as well. I'm going to show you how to do it by taking out a greatest common factor and then factoring by grouping. So we've got 2x squared plus 20x plus 32. Our first step, make sure it's in standard form, and in this case, this is in standard form. We're going from the highest exponent to the lowest exponent. Then we got to see if there is a greatest common factor. Well, in this case, each term contains at least a 2, so we can factor out the greatest common factor of 2. When I factor out the 2, I'm left with a polynomial x squared plus 10x plus 16. Leaving me with an a value of 1, a b value of 10, and a c value of 16. Then I have to find my a times c, so 1 times 16 is going to give me 16. And my b value is 10. So I had to find the factors of 16, so two numbers that multiply to get 16 and add to become 10. So I know the factors of 16 are 1 times 16, 2 times 8, and 4 times 4. The pair that adds up to 10 would be 2 plus 8. So we're going to break up our middle term 10x into 2x plus 8x because that is equivalent to 10x. we bring all the other terms down, so we have an x squared, and we have a 16. And then we factor by grouping. So we're going to group the first two terms together. We've got an x squared plus 2x. We have to find the greatest common factor of that grouping, which in this case is x. So I'm going to have x multiplied by x plus 2. Then we look at our second grouping. We have 8x plus 16. Their greatest common factor is 8. And we're also left with x plus 2. They both have this factor in common, so we can factor it out. We bring our original greatest common factor down, so we have 2 multiplied by x plus 2 multiplied by x plus 8 as our factored form, or our intercept form of the function 2x squared plus 20x plus 32. All right, let's look at the one beneath this. It's x squared minus 4x minus 21. First, we got to make sure that it's in standard form, which it is. Second, we look for a GCF. There is no greatest common factor between x squared minus 4x minus 21. So you can say that it's 1 if it makes it make a little bit more sense for you. And then we go on to do our ABC chart. In this case, our A value is 1, our B value is negative 4, and our C value is negative 21. So now I have to find two numbers that multiply to 1 times negative 21, which is negative 21, and add to negative 4. If they multiply to a negative number, I know that one of the terms needs to be positive and one needs to be negative. But if they add to a negative number, I know that my larger factor, so depending on the two numbers that multiply to get a negative 21, I need to make the larger factor negative, so when I add them together, my final value, my sum, is negative. So I know the factors of 21 are 1 and 21, and 3 times 7. We're going to make those larger factors negative. 1 plus negative 21 would give me a negative 20. That's not negative 4. But 3 plus negative 7 is negative 4, which means I can break up my middle term, this negative 4x, into the equivalent form of 3x minus 7x. And I'm left with x squared and negative 21 on the outsides. Then we factor by grouping. We group the first two terms. We've got x squared plus 3x. Their GCF is an x. And its factored form is x plus 3. Then we have negative 7x minus 21. Both of these terms are negative, so we're going to want to take out a negative factor. We don't want a negative leading coefficient, so take out a negative factor. 7 can go into both terms, so I'm going to divide both of them by a negative 7. Now I'm also left with a grouping of x plus 3 inside my parentheses. So my final factored form is x plus 3 multiplied by x minus 7. This form is our intercept form of the function x squared minus 4x minus 21. Both of these are equivalent expressions. Lastly, we go into 4-term polynomials. First thing we gotta do with 4-term polynomials is make sure it's in standard form. Well, it looks like we have our highest exponent value, which is our cubed value, so to the third power, leading. Then we have second power, first power, and then we have 0 power, which means there isn't a variable for that last term. So that's good. Second thing we need to look for is the greatest common factor. We've got 20n cubed plus 10n squared plus 30n plus 15. They all have a greatest common factor of 5. So I'm going to factor out a 5 from each term. You want to make sure you do this first, because if you don't, it's going to mean that you're going to be left with a factor that still has a greatest common factor in it. At the end, you'll also have to factor that out because we're trying to get it to its most factored form, which is going to be your intercept form of a quadratic function. So I factor out that 5. I'm going to put a little note here that our GCF is 5. 20n cubed divided by 5 is going to give me 4n cubed. 10n squared divided by 5 is going to give me 2n squared. 30n divided by 5 is going to give me 6n. And 15 divided by 5 will give me a 3. Now that I have a 4-term polynomial, I can factor by grouping. So I group the first two. I've got 4n cubed plus 2n squared. From both of these, I can factor out a 2. And I can factor out an n squared. I look at their variables, look at the exponents on the variables, and I look to see which one has the lowest number of, or the lowest exponent value. So in this case, it's an n squared. That means I can at least take an n squared out of both terms. So I'm going to have 2n squared multiplied. Well, 4 divided by 2 is 2. I had n cubed. I take away 2, so I'm just left with an n. Plus 2n squared divided by 2n squared. Those are the same thing. And anything divided by itself is 1. So I'm left with 2n plus 1 as my factored form. Looking at my second grouping, I got 6n plus 3. 3 is the greatest common factor from this grouping. 6n divided by 3 is a 2n. And 3 divided by 3 is 1. So finally, I bring down my original greatest common factor, which is 5. That is going to be multiplied by this 2n plus 1, which both of our factored forms above share. And my last grouping is going to be the 2n squared plus 3. Alright guys, and that's how we factor 2-term, 3-term, and 4-term polynomials.